Okay, so let's take a look at this example right now, and this is a different type of problem from what we looked at before. And I want you to pause here and figure out, why do you think it's so different? And we're going to continue. I'm going to tell you why it's different. Well, we have a cosine value or a trig function value given, and we need to find an angle, convert it into an angle, and then find the sine. Okay, so or a trig value. Before we were looking for an angle. Now we're looking, in the end, now we're looking for a sine value or a trig value in the end on the output. And actually, it's interesting because in this type of problem, we can bypass finding the angle altogether. Well, how do we go about solving this problem? Well, basically, again, let's write out what do we have actually, and what are we asked. So from this problem, we know that the cosine of our angle theta is 4/5, right? So that's what they're telling us. And they're asking, what is the sine of theta? Basically, find the sine of theta when the cosine of theta is 4/5. Well, we can apply our Pythagorean identities to solve this kind of problem. So let's do it. We know that sine squared theta plus cosine squared theta equals 1. That's our Pythagorean identity. So from here, sine squared theta plus 4/5 squared equals 1. So sine squared is 1 minus, and this squared is 16/25. So we have a sine squared theta is 25 minus 16 is going to be 9/25. Now, normally, if we were to solve this problem, and we would unsquare the sign, we would have positive or negative root of 3/25. Sorry, 9 out of 25, which will result in positive or negative 3/5, 3/5. Okay, but here we have actually the inverse cosine function inside. And we know that the range of the inverse cosine function is the top half of a circle. So our angle is in the top half, and all the sine values there are positive. And that is why when we select the solution to this problem, we're going to say that sine of that angle, the cosine -1 of 4/5, is the positive 3/5. That's your answer. Let's try one more problem like that. We have an inverse tangent inside, and we need to find the sine of that angle. Okay, so what are they telling us? They're telling us that the tangent of theta is equals 7/4, and they want us to find the sine of that theta, right? Okay, again, we can use our Pythagorean identity. So if we draw this triangle, this is our angle theta. The tangent is 7/4. So opposite over adjacent, we have 7 over 4. What's the hypotenuse? Well, we can always find the hypotenuse, which is going to be the square root of 65. So now what's the sine? So the sine of theta, by the definition, is opposite over hypotenuse. So what we have is 7 divided by the square root of 65. But then again, if we want to actually rationalize the denominator, then we're going to have 7 roots of 65 over 65, and that's the final answer. We could find the decimal approximation of that value as well. And the last problem that we're going to have in this video is example number 9, and it says find a simplified expression for the cosine of the inverse sine of x over 3 for the values of x between -3 and +3. So again, let's say, what are they asking? They want to find the value of the cosine theta when sine of this theta is x over 3. And so let's take a look at the domain. So domain says x is between -3 and 3. So that ensures, so if we divide our x by 3 and both sides, I mean all sides of this equation by 3, we are going to get x over 3 is between -1 and 1, which ensures that we have the right value, the value in the domain of the inverse sine function. All right, so how we're going to go about it? Well, again, we know this kind of, we have the expression for the sine of theta. We need to find the cosine of theta. So we're going to use our Pythagorean identity, cosine squared theta plus sine squared theta equals 1. So we're gonna plug in our value that they gave us for the sine, which is x over 3, and that should be equal to 1. So cosine square is 1 minus x squared over 9. Now we need a common denominator. So we're going to rewrite 1 as 9 over 9 minus x squared over 9, and that's going to give us 9 minus x squared over 9. Okay, but now let's unsquare the cosine. So normally we're going to get a positive or negative root of 9 minus x squared over 9. And we're going to separate the root, write the numerator separate under the separate root and the denominator under the separate root. So again, simplifying will give us positive and negative a root of 9 minus x squared over 3. Now be careful, 9 minus x squared does not simplify. It does not become 3 minus x. Be careful, don't make that mistake. Now again, we need to choose the positive or negative value in the light that of the fact that we're dealing with an inverse function, so there are restrictions there. Since we have the arcsine function in the argument of the cosine, that arcsine function will spit a value between -pi/2 and pi/2. So on this side of the circle, and all the cosine values on that side of the circle are going to be positive, and therefore for the solution to this question, we're going to select a positive square root value. So in the end, the answer is going to be okay. The cosine of the inverse sine of x over 3 is going to be the positive root of 9 minus x squared over 3. And that's the answer to this problem.